I'm part of the EC2 product team at AWS. And I've been with AWS for a little over 7 years now. And it's been a fascinating ride. I have managed this hardware accelerated business for the last 6 or 7 years. And the amount of growth and excitement that we have seen in this space is just phenomenal. So I'm super excited to talk to you guys about some of the nuts and bolts around the infrastructure that we are building and deploying in order to power the latest Gen AI applications. And I'm super excited to have my co-presenters. We have Alexandru Costin from Adobe, who is a vice president for their generative AI platform. And he's going to talk about how Adobe is leveraging Gen AI for their applications and also how they're leveraging AWS to accomplish their goals. We also have Belinda Zhang. She's a director of engineering with our retail team. And as you guys can imagine, Amazon.com is a really big user of deep learning and Gen AI technologies. So she's going to show a little bit behind the scenes around how we are powering some of our customer experiences on Amazon.com, what are the core technologies we are building, and again, how she is leveraging and her team is leveraging AWS, right? So quick show of hands. How many of us have heard this term Gen AI? Just kidding, I'm sorry. I know this session, this keynote is all been about, this week has all been about Gen AI. In fact, this entire year has been all about Gen AI. And it's all thanks to ChatGPT. And the interesting part is like these kind of models have been around for good 3 to 4 years. And it was that inflection point where masses of consumers were able to kind of harness its power to actually enhance their own productivity and truly take advantage of what large language models and Gen AI has to offer. Now, the phase we are in right now is a super interesting phase where lots of large enterprises like yourselves are now like getting super serious about like taking a look at this technology and understanding how they can leverage it. In fact, there was a research from Goldman Sachs that came out earlier this year that predicted that in about 2 or 3 years, there might be a $7 trillion GDP growth worldwide based on Gen AI, right? So a fascinating growth opportunity for all of us in the room and obviously the entire tech industry. Now, Gen AI is transformational across a whole bunch of industries. You guys are already pretty familiar with, might already be familiar with this. I'm not going to spend too much time on the slide, but across healthcare, life sciences, FinServe, retail, media, and entertainment, there are just lots and lots of use cases where not only large tech companies like ourselves, but our customers like you guys are really envisioning how they can really upgrade the customer experience. So simple things like a digital scribe that's accompanying doctors and healthcare practitioners to drug discovery or operational efficiencies, and even simple things as call center engagements, right? So there's just a lot of value to be unpacked by leveraging this technology. On the AWS side, you guys might have seen like a stack chart from us that talks about all the different services that we're building. I'm not going to reference that slide, but I'm just going to share our thought process and our general high-level strategy around how we are thinking about supporting Gen AI applications, right? So first and foremost, we have mentioned this consistently over this entire year. We don't think that there's going to be a single model that's going to be sufficient for all different types of use cases. In fact, it's just not going to be cost effective, right? So the more larger a model gets, the more complicated it gets, the more expensive it gets, and less specific it gets in some of the certain use cases. So from an AWS standpoint, we want to make sure we offer a portfolio of capabilities that includes a collection of foundational models that you guys can leverage directly. We understand really, really well that enterprises are going to differentiate based on their data. You guys are supporting your customer base, internal or external, and have a fairly good understanding of how they're using your products and services, and how you can leverage data to optimize their experiences or deliver incremental efficiencies. So from our standpoint, if you have very, very sharp focus on making sure that you're able to leverage this tech in a secure, reliable manner and really tune it to based on your organizational needs and the data sets that you have around your systems. We also understand that there are going to be top-level applications that are going to be useful. It's not just about tooling. It's also about like end applications. And lastly, we've got a very strong focus from an infrastructure perspective to provide the most performant and as low cost as possible infrastructure to support these Gen AI applications. And this is a segment that I'm going to focus very deeply on. And then Alexandru and Belinda are going to jump in and talk about how they're leveraging all of AWS to kind of build their services. All right. How many of us have seen a slide like this, by the way, that talks about model parameters and how they're growing over the last few years? Many of us. I see a whole bunch of head nods. So over the last 4 years, there has been a dramatic increase in the size of models, right? And in this case, as we're showing, it has gone up 3,000x. It's just crazy. Now, a lot of times I get the question, it's like, why is this happening? Like, why are the researchers pushing the boundaries in these particular dimensions? And if you look through a whole bunch of research papers, the answer to that question is relatively straightforward, right? So if you look at this particular chart, this is from the famous Llama 2 paper that Meta published a few months ago. The y-axis is the training loss. Like, so the lower the number gets, better the model gets. The x-axis is the amount of tokens or amount of data that is used to train that model. And the different traces you see are different model sizes, right? So if you look closely enough, you have the red line that is 7 billion parameters, and you have the pink line at the bottom that is 70 billion parameters. So a larger model trained with the same amount of data yields better output, right? So that is the key thing that is propelling all these researchers to think through like building larger and larger models, because ultimately, if you're interacting with a chatbot, or if you have an agent that is like generating code for you, or if there's a recommendation engine that is making recommendations for your customers, you want it to provide better and better results that are directly mapped to positive business outcomes. Now, besides that, there's also this common ideology around the scaling law, right? So we talked about how, as a model gets larger, it tends to perform better. There's also this multidimensional correlation with the amount of data that is used to train, and then ultimately the amount of compute that is needed in order to carry off that training, right? So you see this chart where on the second chart, the left axis is the amount of compute that is needed to train, and the right axis is the amount of data. So there's both of these actually axes are logarithmic axes, right? So there's an exponential increase in the amount of data that you need to train your model and the associated compute, right? So let's bring it down. Let's look at a specific example of what that really means. So if you are training, let's say, a 520 billion parameter model, and you use 8K H100 GPUs, it's going to take you 20 weeks to train that model, cost you $80 million, and you're going to consume 43 gigawatt hour of power. This, my friend, is the main reason why there aren't enough GPUs to go around and why NVIDIA's market cap has exceeded $1 trillion, right? Because, again, there's just a lot of compute that is needed in order to kind of train these models. So let's take a look deeper, right? So what type of compute are we talking about? For the most part, if you look under the covers, and many of you in the audience might already be aware that training and ultimately inferencing a deep learning model requires a whole bunch of matrix multiplications. So if you have a CPU that has tens or maybe hundreds of processing cores, surely it can parallelize across those 100 cores, but it's not going to be as effective as a GPU that has thousands of processing cores. Some of the latest GPUs from NVIDIA have 7,000 processing cores, right? So you can imagine being able to kind of parallelize all those math operations across all these thousands of cores and get a job done very quickly. In fact, the entire industry around deep learning was supercharged about 10 years ago by a simple PhD researcher who actually took a single model and trained it in a month using 2 GPUs. And that just kind of took the industry by the storm. And the model was called AlexNet that came out 10 years ago. And there was a paper that particular individual had presented. And it just unlocked the entire innovation in the deep learning space. Now, the slide on the right, custom silicon. That is super important also in this space. Like once you get to a point where you have a lot of volume around the type of workload, you can actually cost optimize and performance optimize by building your own custom chip that is just targeted for that particular use case. So in the case of a custom silicon, you have a clean blank slate, and you can actually design that particular part to deliver the functionality and the capability that you're looking for. And this is where we have been investing across the spectrum on the AWS side, specifically on the compute side. So if you look at the bottom portion of the stack, where EC2 instances, we have instances that feature NVIDIA GPUs. We have been first to market with V100-based instances, A100 instances, and first major cloud provider to launch H100 instances. We have also silicon from other partners. And then over the last 5 years, we have been building our own silicon to accelerate deep learning applications, so specifically Trainium and Inferentia. And it's not just about compute. It's about storage. It's about networking. It's about managed services. And ultimately, it's about ease of use for the end user by integrating into common ML frameworks like PyTorch, TensorFlow, Hugging Face, and also OpenXLA, right? So this is the entire pool of capabilities we are actually optimizing month in, month out to kind of deliver you guys the capability you need in order to build your own Gen AI applications. Quick flyby on Nitro. Nitro is a core fundamental technology that actually enables us to build and launch these instances at a really quick pace. It consists of multiple components, a Nitro chip that is on the motherboard, a Nitro card that's in the server, our own hypervisor. So there's tons of innovation that we have brought in the hypervisor and the virtualization stack to enable us to get to market quickly and provide you guys with the most performant platforms, right? So a quick overview of Nitro. So this is the pre-Nitro configuration, right? So this is circa, I would say, 2014, 2015 timeframe, where a host system is a single server. And on the same server, we have these customer instances that you guys launch and utilize that were managed by the hypervisor layer. And we have the DOM0 that was consuming resources on the server to run a whole bunch of management tasks, which includes like EBS activities, like a launch control of the instance lifecycle, local storage, and things like that. With Nitro, what we did was we took all that management overhead and offloaded it to a dedicated card that was in the server itself, right? So now on the host server, almost entirety of the compute resources, memory resources were available for us to provision to customer instances, right? So as you can see, the decoupling of this architecture allows two things. First, it allows us to move faster in kind of bringing new products to market. And second, and more importantly, it allows us to maximize the utilization of these compute resources and pass on those cost savings to you over time. Quick look at what a typical server looks like. So this is an image of a C5N server that we shipped a couple of years ago. It's not the entirety of the server. You can see in the back there's empty spaces of stuff that we haven't populated there. But you can see the two CPUs. There's a motherboard there. And I want to call out these two particular cards. So these are Nitro cards. And again, there isn't just a single Nitro card, but there are actually two Nitro cards on the server. Where there's one primary card that manages a control plane, our EBS volume, our VPC encryption, and the other one, we can actually use it for networking. Now, on the Nitro side, we have been innovating over the last 10 years, right? So we are on our 5th generation of Nitro chips. And if you take a quick look at the image in the middle for Nitro 3, and you look at that chip, and then go back and look at that red card that we have in the server, you'll see that the same red chip is there. So this is, again, a C5N server that we shipped a couple of years ago with our Nitro 3 chip, right? So we have been building chips for the last 10 years, and we have been actually building a lot of expertise around how to actually build these systems and how to actually scale them out over millions of servers that we have deployed over the years. Quick overview of P5. By the way, how many of us in the room are actually training their own models versus consuming high-level services? Show of hands. I see some. Great. So P5 is a really great platform for training large-scale models. And it's also actually a great platform for fine-tuning. So it is the latest H100 GPU from NVIDIA. 2.5 to 4x higher performance than our prior generation P4D instance. It's got 8 GPUs in the platform. Industry's highest networking capability of 3,200 gigabits per second. When I joined AWS 7 years ago, the maximum networking bandwidth we had was 50 gigabits per second. Now we've got 3200. So it's an order of a magnitude, more than order of a magnitude increase in the amount of networking we have been able to bring to the table. So that's a quick look of P5. I mentioned about custom silicon. So again, P5 using GPUs from NVIDIA, really high performance platform. I mentioned earlier about how we are leveraging our expertise in building silicon, Nitro. We also talked about Graviton earlier this week, about Graviton 4 being our next general purpose CPU. But over the last 5 years, and slowly and steadily, we have been executing on building out our own dedicated chips for accelerating deep learning applications. So we have Inf1 using Inferentia 1 that we shipped back in 2020. Inf2 and Trainium1 were made generally available over the last 12 to 18 months. And all of these are like alternatives to other compute options we have in our portfolio. So if our customers are interested in NVIDIA, we want to make sure we've got the latest and greatest NVIDIA products in the portfolio. But if you guys are open to looking at a different architecture that could potentially provide you with 30 to 40 to maybe 50% cost savings, then we want to make sure we have those options in our portfolio. Let's dive deep specifically into Trainium1. It's custom designed for deep learning. And let's look a little bit under the covers, right? So for Trainium1, it's got 2 massive neuron cores. So unlike GPUs where you have thousands of processing cores, we have 2 large processing cores. And within those cores, we have something called as a tensor engine, which is basically a large matrix multiply engine. These cores also support scalar and vector math. You have collective comms engine that actually help offload a chip-to-chip connection. Then obviously you have a high-performance memory to actually provide you with that HBM memory you need on the chip, right? So Trainium1 is packaged up as Trainium1 instance, where we pack in 16 of these chips into a single server. And we ended up getting a really high-performance server that has class-leading performance and at the same time providing a lot of value. Let's dive deeper into a Trainium1 server. So like I mentioned, Trainium1 is a chip. Trainium1N is the server that houses the chip, right? So it's a dual socket system where you have 2 CPUs. And each CPU has a bank of PCI Express switches that connect to another set of Trainium chips. So a single Trainium1 server consists of 16 Trainium1 chips and a whole host of Nitro cards. So you're seeing the blue blocks on the screen, and they're all Nitro cards that we're using for that 1600 gigabits per second of network capability, along with all the Trainium chips that are all interconnected using a hypermesh fabric. From a server standpoint, to help you kind of visualize, like 1/2, like 8 Trainium chips, the part of the server looks like the image on the left. As you guys can tell, the amount of complexity that this subsystem has as compared to the C5N itself is visually understandable. And then we have another one that contains the other a set of 8 chips. And then we have a 2U server head node that actually racks it all together. So when you look at a Trainium1 server, it's actually not a 1U or 2U node, it's actually a 10U product. It's like this big, it's about 48 inches deep, and it's massive, right? So the amount of engineering complexity from the chip level to the server level that we have to deal with is just incredible, right? So besides the compute side, like I mentioned earlier, it is super, super important for us to make sure we have got high performance network that allows our customers to have a large cluster that they can spin up to accelerate their training applications. For a model size that we talked about, 520 billion parameters as an example, you can't train it on a single machine. You just can't. It'll take you forever, and it's not going to be efficient. So customers are scaling out to hundreds of these machines to actually run their training job in parallel in order to accelerate their time to market. For that, is absolutely essential for us to have a high-performance network. This is where EFA comes in. EFA leverages our Nitro card and has a custom protocol, which we call as SRD, that is optimized for low latency and high bandwidth communication. It's something that is unique to AWS, and it's something that we have been investing in over the last 7 to 8 years, right? It's highly scalable, and it's being used by some of the leading foundational model builders to train their models and bring them to market. Lastly, to kind of close on this piece, I talked about clusters, right? So this slide kind of visualizes how we think about clusters. Specifically, it talks about the design of ultra clusters where our customers are able to consume tens of thousands of these accelerators as part of a single entity. So each of those purple boxes at the bottom represents a single rack of compute. This could be P5s, this could be Trainium 1s. And the way we deploy these racks, they're actually in a single data center, interconnected using a dedicated networking, what we call as ultra clusters, right? So this entire thing is purpose-built to support large-scale training. It has petabit scale, non-blocking networking. That means each rack can talk to the other rack at full bandwidth. And we have been innovating, and we are actually on a second generation of this network, which has allowed us to actually scale it out 8x and lower latency by 15%. So besides the compute, the networking, and these clusters, we want to make sure that you're able to kind of use this compute as effectively as possible. So we want to make sure we focus on the storage aspects and also the managed service aspect, right? So we have EBS, local storage, S3, and FSx clusters as key offerings on the storage side, and then SageMaker, EKS, and ECS on the managed services side to make it easier for customers to kind of consume this capacity and build the models. And lastly, all of this has enabled us to support a wide set of customers on AWS, right? So over the last 10 years, we have been focused on supporting machine learning. So we have over 100,000 customers that are building ML applications. And as Swami mentioned this morning, we have over 10,000 customers that are building Gen AI applications on AWS. With that, I would like to welcome Alexandru to actually talk about Adobe and how they're leveraging Gen AI and specifically AWS. Thank you.
Thanks, Jason. I'm happy to be here. My name is Alexandru, and I run the generative AI team and our training platform at Adobe. I've been with Adobe for 23 years, which is a lot. And I've been doing AI heavily in the last 3 to 4 years. And I'll tell you our story, how we got to build the Firefly family of models, how we partner with AWS to succeed. And in general, starting with Adobe's mission, we are helping the world create content and build personalized digital experiences. So we have 3 business units: the Creative Cloud business unit for professionals that want to create content, Document Cloud business unit with Acrobat and PDFs, and we have the Experience Cloud business unit for marketers. So we've been trusted by many companies with their data. They host their data with us, and we help them do marketing better. We help them do document management better and create content. And we're a 4-decade-old company. So throughout our history, since we've started, we've helped our customer base navigate many technological disruptions. We actually created the first one, the digital publishing revolution, then digital photography happened, and internet, mobile era, social era. Many technological disruptions changed how our customers created content, how our customers do marketing, how our customers consume and edit documents. But last year in 2022, we realized that a new era was starting, the AI era. And in 2022, this wasn't clear to a lot of people, actually. I remember the good times where Chetan and the AWS team were talking to us about getting GPUs, and they were a lot of supply. There was supply. There was not the crazy scarcity you find today in Silicon. And we actually decided in 2022 that Adobe needs to embrace this technology and lead, because our customers need to become Gen AI enabled to be successful in this new world. And we've started our journey, which I'm going to present to you today with some of our learnings throughout the last couple of years. And when we went about creating our Gen AI strategy, we decided that at Adobe, because we have all this software for all these customer segments, that we need to train our own foundational models for creativity. And we've decided that our customer needs those to be integrated into the applications they love and use, like Photoshop or Acrobat or the marketing applications. We've decided that our models, we will train them and invest in them. We have a long history of doing research because we want to be in control of exactly the quality and the capabilities those models need to have. And we also decided to train these models in a special way, not training them with data from the internet, but training them on data we had access to, because we had a large catalog of data in our content marketplace called Adobe Stock that gave us the opportunity to train these models in a different way and make them more commercially useful. And also, we've decided not to build our own infrastructure. It's very easy when you look in the short term to say, oh, I'm going to create my own data at Adobe scale. I'm going to have my own data center and invest in it. But in reality, the partnership with AWS enabled us to focus on actually what differentiates us as a company and have our partners help us with the lower level of the stack. And we've managed to launch a lot of capabilities. I'm going to let that video play out, showing what we've been able to launch in the last 9 months. We've launched 3 foundational models, one for images, one for vectors, one for designs, and we've been massively successful. Our customers love it. They see themselves helped by Gen AI, enabled to be more creative, more productive, so they've embraced those capabilities. In Photoshop, for example, the generative fill capability powered by the Firefly image model is the most used feature in Photoshop today, which is very hard. Photoshop is so entrenched in our customers' workflows, but this capability is so great. It's a copilot helping you achieve your generative edits that they are just using it left and right. As I said, deep integration is what got us to have this usage and helping our customers. And we also decided to train on Adobe Stock data, and that data doesn't contain IP, intellectual property, trademark content, or recognizable characters. So when you generate something with Firefly, we know you cannot generate Hello Kitty or Tom Cruise because our model during training has never seen that. So 4 billion images have been generated. And if you look at how we do it, and maybe that's something you might want to replicate in your company, but I took over this job literally 11 months ago. And when I came in, my goal was to create an AI superhighway to accelerate how we bring these Gen AI capabilities into our products. And the way we organized to make that happen, first, we made sure that we have our training data cataloged and high quality and filtered and available for fast distributed training. Then I'm also responsible for our training ML platform. So we don't use SageMaker today. We use a lot of capabilities from AWS, but because we've started building our own internal platforms before SageMaker was mature enough, we kind of ended up having to build a lot of the capabilities ourselves. Now, based on what I saw this morning, there's a lot of new innovation coming from AWS that I think you guys should explore, and I don't think it's worth it to reinvent. But at the time, we were too early, so we needed to build our own framework. So we do have this training platform that operates on top of EC2, and we have a data platform that stores data in Amazon S3 and Amazon Lustre FX. But we build our own code to help us manage these training jobs. Adobe has a large research organization. We have hundreds of researchers, and every summer we welcome hundreds of interns that come and do research with us. And they are organized in labs that are focused on a specific modality. There's an imaging lab, a video lab, an audio lab, a 3D lab, and each of those labs build and create models and train them on top of our platform running in AWS. We also have an applied research organization that is in charge of taking these models and making them production ready, doing the final training. I call it the last 20% of the job that actually takes 80% of the work. There's a lot of fine-tuning, production ready, testing the quality, making sure the content is safe for work. So huge amount of work goes into this applied research model productization. And then we take those models and we expose them as services, both internally for Photoshops of the world and all the products in Adobe Catalog, but also for enterprises and third party. So this is what we call the AI superhighway, and we're organizing ourselves in a way that promotes the fast transfers of creation of models, and the fast conversion of those models into services so they can be consumed by our applications and ending up in the hands of our customers. And we've been this year through a lot of launches. I'm showing here a lot of the models we've launched. In March, actually in Vegas, we launched the first version of our Firefly image model. Then we've integrated it in Photoshop in May. Then we've integrated it in Illustrator in June. Then in Adobe Express, which is our design suite for collaborators, in August. Then we've added capabilities until our Max conference, which was happening in October. We launched the second version of our model. So it's a huge amount of model versions and model types that we launched and integrated them in a lot of places. This seems like we've moved very fast. The reality is, there's a secret behind it, and the secret is we've been working on it for a long time. Adobe Research has existed for decades, and again, we've been doing a lot of research both in machine learning, but also algorithms. And we got serious about generative models in 2020, not using diffusions and LLMs because they didn't exist at the time or they weren't recognized, using GANs, generative adversarial networks. And we've started creating this generative capabilities inside Photoshop under the umbrella neural filters in 2020, and then continued to do that. So we knew at the beginning of 2022 that a big revolution was coming. We could see the signs with projects like DALL-E 1, even if the resolution was very small, we could see that the foundations were being set up for the world of creativity to change. So we got to understand that very early. In the middle of 2022, we've decided to invest heavily into compute and get serious about it and start training our own models. And this is why we were able to get the executive team support and start training our models very fast. Now, in terms of investments in our training, in the second half, we've actually increased the number of A100 nodes by a factor of 20. And they were all reserved instances. In the past, we used to do training jobs on Amazon by using on-demand instances, and sometimes they weren't available, but in most of the cases, they're also more expensive. So we've decided to switch, partner deeper with AWS, reserved instances, and start learning how to do distributed training at a larger scale. Using open source like PyTorch and FSDP and DDP, or the DeepSpeed framework that you might have heard from Microsoft. We've started to learn how to do it, and this enabled us to also reduce the cost per teraflop by a factor of 3 or 4. We've continued to double our investment. In the first half of 23, we've doubled our number of A100 one more time. And again, these are nodes used for training. This is how we train these models. And we also offer them internally to Adobe Research. So many researchers at Adobe can train various models across all of those modalities on this fleet of shared resources that are shared by the whole company. We've learned how to do this ultra-cluster configuration. When I refer here to single spine means that we have this high bandwidth network between the nodes so they can do distributed training very fast. And it's actually twice as fast when you do a big distributed training job. If you're in an ultra-cluster, it's twice as fast as when the nodes are randomly distributed in the Amazon network. We got to also understand what data type to use to train efficiently. It's maybe a secret, not so much of a secret these days, but depending on the data type, the same GPU can give you 2 times or 4 times more teraflops, which is the key. It's a key characteristic that Jason showed in terms of making the model better, consuming teraflops. So when you use a lower precision data type like bfloat 16, you actually get to have twice as many teraflops available with a very small compromise on quality, literally almost insignificant. So a key essence, if you want to train your own model or even do fine-tuning, is to learn how to configure the data type. We've continued to do this investigation and learning about MFU, model flops utilization. So we right now have reports and we look at all the GPUs. And another secret is it doesn't matter if the GPU reports 100%. It can report 100% and have only 5% of the tensor core being used. So it's extremely important to start to understand how do you monitor these GPUs or IPUs like Trainium and optimize your code to make sure all these tensor core are utilized during your training, because otherwise you're basically wasting your teraflops and you can't compete. And we're continuing now to upgrade our fleet to H100 and doing another type of innovation, which is the switch to FP8, which again doubles the training teraflops, doubles the number of inference teraflops. So essential, I would say, skill you need to learn these days is to master your data types. Now, in terms of how we do this training, again, we use EC2, we use Lustre, EBS, EFA for training. We have our provisioning, and we do have, in general, this layered system where we offered our researcher either individual instances they can train on, or we offer them notebooks so they can have an interactive session, or we offer them a multi-tenant batch processing job where they can submit a job, it gets into a queue, and it's scheduled to run. So we keep our fleet of reserved instances continuously occupied. It's very important once you start reserving GPUs to make sure they're being used. And I'm seeing some really interesting offerings with the blocks reservation that was announced yesterday that might enable you to operate differently. But for us at our scale, it was worth it to have this large compute pool shared between all the researchers and implement these scheduling capabilities. And this is how training happens. Various groups in Adobe, they submit these jobs in this multi-tenant training scheduler. These jobs are being distributed. Those are Python jobs. They're being distributed into clusters, subclusters of machines. They run a distributed training, and then they save these checkpoints in Lustre FX. And we do a lot of work making sure that there's a fair distribution of those resources, that we have a portfolio management of how compute is being distributed between teams. And again, we're investing now into a deeper analytics on our compute spend. We do this model flops utilization report to our CFO, and we show exactly for all the experiments that if somebody's doing some training jobs, because they can cost hundreds of thousands or millions of dollars, we have exact reporting not only on exactly how much a particular experiment did cost, but also how did they use the compute? How did they use the streaming multiplier, which is basically the tensor core? Did they use the tensor core correctly or not? And what is the amount of teraflops they're using? Because in the end, that's what you pay for. That's what will make your model better, the number of teraflops you're spending training this model. And this was on the training side. We also have the Firefly models are also hosted in AWS or inference. We have a stateless system, basically multiple regions, and we do round robin through these regions. The models that we have today, we optimize for quality, so they take 10 to 15 seconds to generate an image, for example. And it's a teraflops game also. So it's very important to make sure you optimize your code for inference too, because this will make your generative AI model, as a business, it will make it profitable. Otherwise, you might end up paying too much and not offering enough value to customers. So we're doing a lot of investment in making sure that our code is optimized for inference and exploring, for example, more recently, the Inferentia 2 chip to make sure we get the best value possible for the silicon we're getting in Amazon. This is a directional chart showing some of our history since we launched. You see a huge spike at the beginning when we integrated it in Photoshop. Photoshop went viral, and we actually, at the time, were still doing inference on P4, on A100 chips. This was before the LLM craze and the silicon scarcity happened. So we realized very fast that there were not enough A100s available, so we switched to A10G, which is the other G5 node from AWS, and we went through this process of moving all our inference to chips optimized for inference, and then continuing to do optimizations and improving our models, et cetera. But it's very important to be able to switch between the silicons because they're still not available. So again, focus on finding the best silicon possible. The great thing about AWS, they do offer multiple silicon types, and NVIDIA ones, they're right now, at least on the training side, in high demand. But I think on the inference side, both between Inferentia and A10G, there's more availability. So to sum up, this was the Firefly story. Again, we were very lucky to participate in this Gen AI revolution from the beginning and ship something in market relatively early, train the models before the silicon was very scarce, and build up a lot of expertise. But my advice to you, that if you're not a company at the size of Adobe and you can't attract the right amount of talent, both in terms of research and the engineering and the inference and the training kind of ML expertise, applied ML expertise that's needed, is to look at the stuff that was announced today, the systems like Bedrock and SageMaker. Make sure you focus on the differentiating Gen AI value you can bring on top of what's already there, because it's going to be really hard to rebuild from scratch and train your own models. But I want to thank Jason for the partnership and invite Belinda on stage. Thank you.
Hey, thank you, Alejandro. Hello, everyone. Have you been enjoying reInvent? Yeah. Thank you for staying late for our presentation. As Chetan introduced, my name is Belinda. My team builds a large-scale foundation model at Amazon. So our team's goal is to try to change the way deep learning systems are built and deployed at Amazon. And by doing so, we try to lift across Amazon the services beyond the current state of art, and meanwhile unblock many new downstream applications. So for today, I'd like to share some of the Gen AI capabilities we have enabled and how we leverage AWS infrastructure to build a delightful Amazon shopping experience. So one of our core products are semantic representations. And we build that for e-commerce specific entities, such as the products you and me purchase on Amazon, or the queries we type when we try to search those products. So what semantic means in this context is our focus is try to capture the meaning of the data, leveraging the large language model technology, instead of simply matching the exact keywords. Why that is important is we try to really capture build the good representation for the real world entities. And the semantic understanding can help us build that explicitly. And in the end, there are a lot of literature, a lot of research to show that this can help to improve many machine learning application performance. So build a well-performing semantic representation requires massive amount of data. So as we can see on the right hand of the slide, this is an example of a sample product detail page on Amazon. We can see a lot of rich product information. We can see product title, description, bullet points, customer reviews, the product ratings, the pictures of the products, and many products has videos. And on Amazon, we have billions of product pages like this. So this gives us a lot of the ingredients to pre-train our foundation model on top of those hundreds of billions of rows so that we can scale to hundreds of billions of parameters. For semantic representation, we have identified 5 key pillars: multimodal, multilingual, multi-locale, multitask, and multi-entity. So first and foremost, our representation, our models are multimodal because Amazon data are available in multimodalities. Like what we just saw, there's unstructured text data. There's a structured tabular data for product specs. Many products have images and also associated videos. So what we want to do is we want to capitalize across board on top of those massive diverse modality information. Our model are also multilingual because Amazon sell products on several dozens of countries. And meanwhile, a lot of those product informations are specialized for the locale in which it is sold. So that we want to also build our model on top of the data from multiple locales. Meanwhile, we also leverage multitask learning for a variety of Amazon tasks to capture different facets of the product information. Because in the end, we build a model for usage for every team in Amazon who will leverage the model to solve different type of customer problems. Last but not least, the relationship between different entities also super critical. For example, we want to know what kind of queries do customers type when they search for what type of products sold by which seller. So understand that the relationship is super critical. So we want to build our representation leveraging the relationship of multi-entities. So those are the 5 key pillars. And as a matter of fact, that's how my team is called M5. That's actually how my team's name comes from. So let's jump in several applications. I'd like to share with you some models we have developed over the years and how they transform the Amazon shopping experience. The first example is a spelling correction. So Amazon search vision is actually to help customers search effortlessly. So spelling correction is a feature can help you and me to get what we want without even knowing the exact spelling of the intended word. Historically, the spelling correction team, they leveraged classical machine learning algorithm on top of intensive manual feature engineering techniques to build this application. That's very time-consuming and also have a cap for the performance. So a couple years ago, we've been working closely with the application team, explored a number of deep learning approaches, including a sequence-to-sequence generative modeling architecture that we built. And that was a state-of-art LLM architecture, and we proved that to perform really well through both offline and online experimentation. And our success also demonstrated in the multilingual use case, because we do not just want to do well for US, but also want to excel in all the primary languages across all Amazon marketplaces. So we pre-trained our foundation model on large multilingual data. So that also helped the model achieve state-of-art performance across different languages and different locales. A second example is AI-generated product images. So here, we would like to generate pictures for bathroom with a set of specific specifications, including furniture, accessories that we want to show on the image. In this case, if we see the prompt, the key phrase in the prompt is wooden ladder shelf, which is a very common product type we sell on Amazon. So in this case, when we compare the 2 rows of the images, the one on the bottom produced from our in-house model, we can see the wooden ladder shelf is actually shown across all the images, compared to the top row where the images are produced from the public open source model, where we can see the wooden ladder shelf do not show on all the images. So that is an example highlight the importance of in-domain training based on Amazon catalog data that can help us produce the output image more closely aligned with the product use case we care about. The last example I want to show is on the video foundation model, which is pre-trained on Amazon product video dataset. For this ASIN face-out application on search result page, if a product has a relevant video associated with it, our model will be able to instruct the application to match the query and the relevant product video. And then the preview of that product video will be autoplayed. And if a customer click on that preview, the video will automatically expand and play in full video in the ASIN listing. So that is a very cool feature to help our customers getting useful product information much easier when they try to search the product. All right, so that's some examples for the applications models we have built. So here I'd like to share some of the key challenges we have got into along the way, and how leveraging the AWS technology can help us solve that. So at the root, our team has a customer-obsessed science flywheel. So on one side, we would like to focus, we pursue customer-centric science. And by doing that, we strive to delight the customer shopping experience. That motivates us to keep pushing the cutting-edge technology envelope, which in turn give us a lot more opportunities to delight the customer in the deeper level. However, in the process, we have seen a lot of challenges. Number one, compute hungry. Because we are running more than 10,000 experiments every month, and all of those experiments are compute intensive. And two is access to accelerators. We actually run our experiments on accelerators, and getting access to a diversified accelerator on AWS can greatly help us increasing our experimentation velocity. Last but not least, we also want to make our developer effective, because developers are the crucix of our system. Reducing their toil, reducing the number of things they need to worry about is actually going to make an outsized impact to our success. So I want to share with you some of the solutions by partnering with AWS we have got along the way. So for the first challenge, we want to increase the cost efficiency of our training fleet. So in this way, we worked closely with AWS Batch to adopt their fair share queue in our fleet. Because we are running one of the biggest fleet in Amazon. Previously, we used to manually allocate those capacities, those resources, for different work streams within the team. And for each team, they also need to manage their own queue for their experiments. This actually led to suboptimal resource allocation and a lot of idle capacities, because when the team taking a break, those resources are just sitting idle. And meanwhile, just manual resource management normally require a lot of alignment and resource movement across queues that generates a lot of huge waste. So therefore, earlier this year, we worked with Amazon, the AWS Batch team. We onboard the fair share queue system. By doing that, it actually gave us an opportunity to use soft allocation based on the prioritization across work streams. And the rest of the stuff is taken care of by AWS Batch. So AWS Batch will make sure the resources are managed in a fair way based on the prioritization target we set. By doing that, we actually reduced our idle capacity from 25% to 10%. So a great win. A second challenge is the access to compute, like what I shared. All our experiments require accelerators, so we try to build access to a diverse set of accelerators to increase our experiment velocity. So specifically, we have started using the AWS Trainium for model training and the AWS Inferentia for model inference. So specifically for this slide, I want to quickly talk about the Trainium. The Trainium machine, at least the TRN1 machine, give us a very nice 50% better price-performance ratio compared to P4 machines. Even though we still use a lot of GPUs, but the Trainium is a very good choice, especially when we have very mature model architecture and workload. So today we use Trainium in two ways. One is we use Trainium for model refresh pipeline. Model refresh pipeline is the model architecture and workload already fixed. We just need to keep training using new production data week over week to maintain the good performance. Because everything has been fixed, so the migration can be easy. We just need to revise the training script and and the model to make it XLA compliant. And we have achieved using less than 100 lines of code to do that, and still achieve the throughput parity and the model performance parity with models trained on GPUs. The second approach we use the Trinium is we use the GPU and the Trinium checkpoint compatibility to make the Trinium adoption a two-way door decision. So how to think about that is we perform the initial experimentation and exploration using GPU. But once we finalize the hyperparameter, the model setup, we will use the GPU checkpoints. We move that to Trinium, and we'll continue to train the model until we reach model convergence. So in this way, we have the flexibility to leverage the best possible accelerator for our purpose, but meanwhile achieve a lot of the training cost reduction. Also want to quickly talk about inference. The inference instance also have a really nice price-performance ratio. So all the techniques I just mentioned apply to the inference here. So we, again, leverage the checkpoint compatibility to train on the GPU. So sometimes we train on the GPU, but inference on inference, again, want to optimize the price performance for any given model. Finally, let's take a look at the developer velocity. So how we made the M5 developer productive and reduce their toil. So most of the times, the training workload need to run for weeks, but the compute assignment could be taken away at any time. So that actually caused a lot of churns for our developers. So in this case, we launched a feature called auto resume. So in this case, we checkpoint for the model training process in an asynchronous way. And then we continuously save the asynchronous distributed checkpoint on S3. This is a cheap option for storage. So I want to show you the flow for the entire pipeline. Because our job training utilizing the same job client, so the whole pipeline is very simplified. So every time when we start the training, we just fetch the data, raw data from S3, and track the data through Glue catalog. And then the training starts. The data will flow into the training node and will be pre-processed on the fly. And then once the training going in progress, the checkpoint will asynchronously saved in S3. So that saves a lot of the churns, and so make sure we are making progress in a smooth way. So, just to give you some examples on the challenges and solutions. And over the past 3 years, we have achieved great success thanks to the AWS solutions. For example, we have got 500 applications onboarded our model, and among that, more than 130 have seen significant improvement of performance. That drove more than 50 customer application launches. Altogether, we have created more than $1 billion incremental sales and contributed to hundreds of millions of dollars saving. So yeah, just want to say thank you for the partnership from AWS. We strive to work together, build the best place to build the Gen AI together.
Yeah, great. Thank you, everybody, and thank you, Belinda and Alexander. Really appreciate it. We'll hang out after the session to take any questions. So again, thank you again so much for your time. Appreciate it.